Welcome back to our next video. In this video, we will be looking at qualitative analysis. So we are going to be making some deductions based on observation. So for this experiment, we have some solutions of ions, and we are going to identify them based on whether or not we see the formation of a precipitate, and specifically this reaction is going to be done using sodium hydroxide. So we're going to add a few drops of sodium hydroxide to each solution and see what happens. So if you did biology or integrated science and you know about the food test, you know that if you add iodine solution to a sample containing starch, it should turn blue-black. So based on the observation, you would know that the food sample contains starch, because once you add iodine solution and get the blue-black color, that's an indication of starch. If it was the Benedict test and you use the Benedict solution and heat it, and you get the orange color or yellow depending on the concentration of the sugar, then you know that reducing sugar is present. So we're going to look at what happened now when we add sodium hydroxide to these solutions. Alright, and I'm going to tell you the name of each of them. So you need to remember this for test purposes. Alright, so the first solution is copper sulfate, copper 2 sulfate. Alright, and clearly it's a blue solution. Now I'm going to add a few drops of the sodium hydroxide solution. Right? And let's see what happens. Now you can see a precipitate being formed. Let me add a little more. Alright, so clearly there is a blue precipitate at the top. Alright, so based on this, you know that if you add a few drops of sodium hydroxide to your solution and you get a blue precipitate, that is indicating copper 2 sulfate. So whenever you add a few drops of sodium hydroxide to a solution, if you get the blue precipitate, it's copper sulfate. Alright, this is iron 2. Let's see what happens when we add a few drops of sodium hydroxide. And again, hold on. So again we see, you can see here, we are getting a green precipitate. Alright, so we add a few drops and we get a green precipitate. Alright, this is iron 3. So this is iron 2, the green, and this is iron 3. Let me squeeze it. Alright. So again, you can see we are getting a precipitate. This one now is magnesium. So you can see here we get a white precipitate. Okay. The next one is lead. Right. Again, we have a white precipitate being formed. Next one is zinc. Alright, so here again we are getting a precipitate being formed. So if you notice, magnesium, lead, zinc, so far, they have formed a white precipitate when we add a few drops of sodium hydroxide. Now let's move on to, this one is aluminum. Alright, again, white precipitate being formed. Alright, so remember, all of these solutions were colorless, just like this. And when we add the sodium hydroxide, we got a precipitate. Well, not all of them, obviously, but starting from magnesium, come down. Then the final one now is calcium. Alright, again, here we have white precipitate being formed. Alright, so clearly all of these solutions formed a precipitate when we add a few drops of sodium hydroxide. Now what we're going to do is add the sodium hydroxide in excess. So we're going to add an adequate amount, right? And then we are going to see if the precipitate remains or if it dissolves. All right, so here we have, let me start with zinc. This is calcium, this is aluminum, this is zinc. All right, so clearly we see that the precipitate is dissolving. It doesn't completely dissolve. If I add more, it will. All right, but clearly we can see dissolving, right? Now let's look at copper. Clearly that's not the same as with zinc. So if you look here, let's compare them. This is copper sulfate. Clearly the precipitate is still in there, but this one is being dissolved. All right, so this one is zinc. When we add the sodium hydroxide in excess, the precipitate is dissolving, right? But with this one, the precipitate, it remains. Right? So those are key observations. So let's go in order now. So this was copper sulfate. When we add this sodium hydroxide dropwise, you got a blue precipitate, right? When we add it in excess, the blue precipitate, it remained. The iron 2, green precipitate. Let's add it in excess and see what happens. Alright, clearly the precipitate is still there. Alright, see for yourself. That's it. Precipitate is there. Right. Iron 3. Precipitate is there. So far, copper sulfate, iron chloride, iron 2, this is iron 3, all of them, the precipitate remained. Next in line is magnesium. Alright, precipitate is there. As you can see, it's not like with zinc. Then this one now is lead. Let me add some. Oh. Alright. So let me just take up back magnesium so I can compare. Alright. So you see the precipitate is still there for magnesium, but for lead it dissolved. Hence white is completely colorless. Alright, magnesium, lead. So it's magnesium, lead, zinc. So before, when we add them dropwise, right, we could not differentiate if I gave you just one particular compound, right, and it is a clear solution at first, and you add a few drops of sodium hydroxide and you get a white precipitate. It could be any of these down here. It could be zinc, it could be magnesium, calcium, aluminum, right, lead, any one of them. So you cannot just add it dropwise to tell the difference, because it could be any of these 5 ions that are present. Good? So you would do a further step and add it in excess. So far, when we add it in excess, we see that the calcium, the precipitate, it did not dissolve. So by adding it in excess, we can eliminate between the calcium and the zinc and lead, because the precipitate in zinc and lead, it dissolved, but the one in calcium did not. All right, so when you add it in excess, if the precipitate remains, sorry, not calcium, this one is magnesium. So if the precipitate remains, it means it could be magnesium. If it dissolved, it could be zinc or lead. Let's do the other two now. So this one was aluminum. All right, let's add it in excess. All right, so we see the precipitate dissolving in this one already. All right, not completely, I would have to add more, but clearly you can see that the precipitate, all right, it's dissolving. If you notice calcium, it's still there. This one is colorless because the precipitate dissolved. So that means for lead, zinc, and aluminum, the white precipitate dissolved when you add the sodium hydroxide in excess. And the final one is calcium. Alright, clearly the white precipitate did not dissolve. So if you have a solution, right, an unknown solution, it's colorless, clear. Well, not clear, because clear, it's colorless. When it's colorless, if you add the sodium hydroxide and you get a white precipitate, it could be magnesium, it could be, this was lead, zinc, aluminum, and calcium. It could be any one of them. When you add it in excess, if you get a white precipitate, it could be magnesium or it could be calcium. But if it dissolved, it could be zinc, aluminum, or lead. Alright? So the next part now is that we are going to use it instead of sodium hydroxide. We are going to do all of these experiments again, all of these solutions using aqueous ammonia. So we're doing it first with sodium hydroxide, and now I'm going to repeat it with aqueous ammonia, ammonium hydroxide. Alright, so I'm going to pause it and set up for the ammonium hydroxide. Alright, so now we're going to do, alright, now we're ready to use our ammonium hydroxide solution. So again, we have the same set of solutions. So starting with copper, and before I do copper, I'm going to do about copper with sodium hydroxide to make a distinction. So again, here is copper with sodium hydroxide. Alright? So you see the precipitate formed at the top. Alright? Now let's do ammonium hydroxide now. So now it's ammonium hydroxide and copper sulfate. Alright. Look at the difference in the intensity of the blue color. So this is with ammonium hydroxide and this is with sodium hydroxide. Both of them give you a blue precipitate, but look at the blue, right? It's a much more deeper blue color, right? This is a lighter blue, right? So sodium hydroxide, it's a blue precipitate. Ammonium hydroxide, you still get a blue precipitate, but look at the color, right? Much deeper blue. Now, let me add the sodium hydroxide in excess. Alright. Just to remind you, right? When you add it in excess, the precipitate is not dissolving, right? Right? The precipitate, it remains. So this is with sodium hydroxide. So I'm making a distinction with copper sulfate specifically when it's sodium hydroxide versus ammonium hydroxide. So I'm going to add the ammonium hydroxide in excess now, and let's see what will happen. Right, I'm just going to pour it. If you notice, we get a solution. You notice it's clear now, so we get a deep blue solution, right? Some precipitates are down here, but if we add enough, everything will dissolve, right? So when you add it in excess, you notice sodium hydroxide, the precipitate is still there, but with this is a deep blue solution that is formed. So this is with ammonium hydroxide. So copper sulfate, or just copper 2 ions in general, you will get a deep blue precipitate when you add a few drops of aqueous ammonia. When you add it in excess, you get a deep blue solution. So the precipitate dissolved, and clearly you see the deep blue solution. And again, there's a little precipitate at the bottom, but if we added more or put it in a beaker, right, everything would dissolve. Alright, so that's copper sulfate, or just let's say it's copper 2 ions. This is iron 2. So again, just like with the sodium hydroxide, you get a green precipitate, right? Nothing changes. Iron 3, you get the red-brown precipitate, right? So nothing changes there as well. Then now move on to magnesium. Alright, we get the white precipitate. Then this one is lead. We also get a white precipitate with lead. Then the zinc. This one is zinc. We get a white precipitate. Let me add 2 more. Alright, so white precipitate with zinc. After zinc, it's aluminium. So this one is aluminium. Alright, so again, white precipitate, we get the precipitate being formed. And the final one is calcium. And if you notice with calcium, we don't have any precipitate. Let me do it again. So with calcium, we don't get any precipitate being formed when you use aqueous ammonia. So let me do it again. You don't get any precipitate being formed. Alright. So what's the difference between the sodium hydroxide and the aqueous ammonia when we use them? So the first difference, with copper sulfate, the blue color formed, it's different. This one is a lighter blue. With the ammonia, you get a darker or a deeper blue color. When you add it in excess, for sodium hydroxide, it is insoluble. But with copper, it dissolves. So it is soluble in excess. So copper ions are soluble in excess ammonia, copper 2. Alright, so that is why we get a deep blue solution. The precipitate, it dissolved. Now, with iron 2, you still get the green precipitate. Now, let us add it in excess and see if it dissolves. Alright, that's enough. Right, and clearly it did not dissolve. So iron 2, it gives the same reaction with sodium hydroxide and ammonium hydroxide. So you get the precipitate and it remains when you add the excess. Let's do iron 3. Alright, that's enough. Clearly the precipitate is there, right? If you notice, it have a rusty appearance, right? So the precipitate remains when we add it in excess. Then magnesium. Yeah, this is magnesium. Alright, clearly it doesn't get colorless. The precipitate is still there. Alright. And then after calcium, after magnesium, so remember with magnesium, the sodium hydroxide, it was insoluble. So magnesium is insoluble in both sodium hydroxide and aqueous ammonia, right? But with calcium, so if initially you would use sodium hydroxide, right? And you get a white precipitate, and you add the sodium hydroxide in excess, and the precipitate remains, it would be magnesium or calcium. So to differentiate between magnesium and calcium, you would then add the aqueous ammonia. If you don't get a white precipitate, it's calcium. If you don't get any precipitate at all, you know it's calcium. If you get a white precipitate and it's insoluble in excess, you know it's magnesium, right? So with sodium hydroxide, you cannot differentiate between magnesium and calcium. Both of them will give you a white precipitate that does not dissolve in excess sodium hydroxide. But when you use, as you can see here, when you use aqueous ammonia, aka ammonium hydroxide, the calcium, you don't get a precipitate, right? But with this one, with magnesium, you get a precipitate that is insoluble. Alright? So that's that. After that one, now we have lead. So let's do lead. Precipitate is still there. So, point to note, remember lead, when we add excess sodium hydroxide, it was insoluble. No, not insoluble, it was soluble in excess sodium hydroxide, but now we can see that the precipitate is still there when we add excess ammonia. So the lead ions are insoluble in excess ammonia. This is something you just have to study and remember. Alright, let me add some, just a second. Alright, so this was lead. Now we're moving on to zinc. Alright, zinc is soluble as well. So zinc is soluble in both excess sodium hydroxide and excess ammonia. Unlike lead, which was soluble in excess sodium hydroxide, but here it is insoluble in excess ammonia. And the other one now is aluminum. All right. So you can still see we have the precipitate there. All right. So looking at the zinc, colorless solution. So let's compare them, right? Oh. So this is lead, this is zinc, and this is over here is, so this is zinc here, sorry, not zinc, this is aluminum, this is zinc in the middle, and lead. All right. So remember, at the end of the reaction with sodium hydroxide, these three would have, the precipitate would have dissolved, right, in excess sodium hydroxide. So if you had gotten a white precipitate, right, using sodium hydroxide, and it dissolved in excess sodium hydroxide, it could have been any of these three solutions, right? Now that we have used the ammonia solution, when we add it in excess, the zinc does not form a precipitate, or the precipitate dissolve. So if the precipitate dissolved, it means it is zinc, right? If you get a white precipitate that does not dissolve, it could either be lead or aluminum, right? And so now we need to determine how we can differentiate between lead and aluminum. And so I'm going to use potassium iodide. So I'm going to go for this solution of potassium iodide and see what will happen. Alright, so continuing now, I have the potassium iodide solution. So I'm going to add it to the solution with the lead ions, and we'll see what happens. Just a second. Alright, so for the lead ions, when you add potassium iodide, you're supposed to get a yellow precipitate like this. Alright, now I only have a little potassium iodide, so I poured out a new solution of lead. So let's see. It's not changing it. Nope. Just a second. Alright, so I'm pouring out just a small amount of the lead. Alright, and let's see if this one works. Alright, yes, so there's it. Alright, so for lead ions, when you add potassium iodide, you should get a yellow precipitate, like we're seeing here. Alright, but I don't have any more potassium iodide to show you with this solution. Alright, but clearly for lead you will get a yellow precipitate, and for aluminum you would not. Alright, so that is that. So just to recap, right, for the colors, for these three, copper, iron 2 and iron 3, those are easy to identify. Copper with ammonium hydroxide, you get a deep blue precipitate, then in excess you get a deep blue solution. Fe2 plus, you get green precipitate, insoluble. Fe3 plus, reddish brown, or if you want to say rusty brown, whichever, or rusty appearance, whichever one you want to use. Alright, then now for the magnesium, you will get a white precipitate that remains insoluble, whereas for the calcium you don't get any precipitate. Right? The reason why I'm comparing calcium and magnesium is because with sodium hydroxide, their precipitate remains in excess, so we use ammonia to differentiate between them. Magnesium forms a precipitate, calcium does not. And then the other three now, lead, zinc, and aluminum, those, the precipitate formed with sodium hydroxide dissolve in excess. But with ammonia, the zinc dissolved in excess, but the lead and aluminum did not, right? With the ammonia. So to differentiate between lead and zinc, we add potassium iodide, and with lead, you will get a yellow precipitate, all right? And that's it. So that's it for this video. I will do a next one with negative ions. So these are the ones for the positive ions. I will do a next video with negative ions, all right? So that's it.